Hello everyone, myself Dr. N. Gopinath, Assistant Professor from the Department of Computational Intelligence, SRM Institute of Science and Technology, Katangalathur campus. I welcome you all for my lecture series for the subject Computer Networks. Today we are going to begin our session with Unit 1, Introduction to Networks. So these were the topics which were covered under Unit 1, that is Introduction to Networks. Let us start with the introduction part. So first I am just defining what is meant by the term network. A network is a set of devices connected by communication links. A node can be a computer, printer or any other devices capable of sending or receiving data generated by other nodes on the network. When we communicate, we are sharing information. This sharing can be local or remote. Next is the characteristics of network. The effectiveness of the network depends on three characteristics. First one is delivery, second one is the accuracy, and the third one is the timeliness. So the delivery defines the system must deliver data to the correct destination. Second one is the accuracy. The system must deliver the data accurately. And the third one is timeliness. The system must deliver data in a timely manner. Next, we will move on to the components that are involved in network process. The first component is a message. It is the information to be communicated. Popular forms of information include text, pictures, audio, video, etc. Second one is a sender. It is the device which sends the data messages. It can be a computer, workstation, telephone, handset, etc. Third one is a receiver. It is a device which receives the data messages. It can be a computer, workstation, telephone handset, etc. Third one is a transmission medium. It is a physical path by which a message travels from one machine to another machine. For example, twisted pair wire, coaxial cable, radio waves, etc. And the last one is the protocol. It is simply the set of rules that governs the data communication. Next is the key elements of protocol. There are three key elements which constitute a protocol. The first one is the syntax, the second one is the semantics, and the third one is the timing. Next we will move on to the transmission modes. The way in which data is transmitted from one device to another device is known as transmission mode. The transmission mode is also known as a communication mode. Each communication channel has a direction associated with it, and transmission media provide the direction. Therefore, the transmission mode is also known as a directional mode. The transmission mode is defined in the physical layer of the OSI layer. Next is the types of transmission mode. There are three types of transmission mode. First one is a simplex mode, second one is the off duplex mode, and the third one is a full duplex mode. First we will see about the simplex mode. In simplex mode, the communication is unidirectional. That is, the data flow in one direction. A device can send only the data, but the receiver cannot receive it. The radio station is a simplex channel as it transmits the signals to the listeners, but never allows them to transmit back. The advantage is the station can utilize the entire bandwidth of the communication channel so that more data can be transmitted at a time. And the disadvantage is the communication in simplex mode is unidirectional. Next is the off duplex mode. In a off duplex channel, directions can be reversed. That is, the station can transmit and receive the data as well. Messages flow in both the directions, but not at the same time. The entire bandwidth of the communication channel is utilized in one direction at a time. A walkie-talkie is an example of the off duplex mode. Advantage is that both the device can send and receive the data. Disadvantage is one device is sending the data, the another has to wait to receive the data. Next is the full duplex mode. In full duplex mode, the communication is bidirectional, that is, the data flow in both the directions. Both the stations can send and receive the messages simultaneously. Full duplex mode has two simplex channels. One channel has traffic moving in one direction and another channel has traffic flowing in the opposite direction. The full duplex mode is the fastest mode of communication between devices. The most common example of the full duplex mode is telephone networks. Advantages: both the station can send and receive the data at the same time. Disadvantages: if there is no dedicated path exists between the devices, then the communication is not possible. Here is a diagrammatic representation of the three different types of transmission modes. And next is a comparison of the transmission mode in a tabular format. Next, we will move on to the first topic of our first unit, that is network types: LAN, WAN, MAN and PAN. Types of networking. The size of a computer network defines its classification. A network can be tiny, containing only one system, or as large as needed. The following are the various types of computer networks. First is the PAN, that is Personal Area Network. Second is the LAN, Local Area Network. Third one is the MAN, Metropolitan Area Network. And fourth one is the WAN, Wide Area Network. So first we will start with the PAN. It is the smallest network of computer. Bluetooth or other infrared enabled devices could be used to connect devices. It has 10-meter range of connectivity. It can cover up to 30 feet in diameter. PAN network enables a single person's personal device to connect with each other. The types of PAN are wired PAN and wireless PAN. Next is the local area network. In a small network, such as a building or a small office, systems are connected. LAN network is low cost. Token ring technology is being used. Two or more personal computers can be connected with nodes. Data transfer is quick and well rated. Next is the wide area network. A network that spans a country or a larger group of individuals. The WAN networks connect telephonic connections as well. And the last category is a MAN. Cable TV connection is an example of a network that can be connected within a city. Ethernet, ATM, token ring and FDDI are some of the examples. MAN network has a wider range of application. This network interface could be used to connect citizens to various organizations. So here is a diagrammatic representations of the types of networks. Next we will move on to the second topic, that is network topology. It is having bus, star, ring, mesh and hybrid. So the term network topology refers to the layout and interconnection of devices within a network. It describes how network components like computers, servers and other devices are connected and communicated with each other. It is crucial for optimizing network performance and reliability. It defines the arrangement of nodes and connections which directly impact data flow efficiency. So the types of network topology are point-to-point, bus, star, ring, mesh, tree and hybrid. So first we will start with point-to-point topology. It is the simplest network configuration connecting two nodes directly through a dedicated communication link. This setup resembles a direct line between two endpoints, allowing for efficient and fast data transfer. Second one is the bus topology. Imagine a long cable resembling a bus route with devices connected along its length. This is the essence of a bus topology. In a bus network, all devices share the same communication channel. Data travels along the cable and each device checks if the data is intended for it. If so, it accepts the data, otherwise it ignores it. Star topology. In a star topology, each device is connected directly to a central hub or switch. All communication between devices must go through this central point. It's like a hub and spoke model, with the hub being the focal point for data transmission. Ring topology. In a ring topology, each device is connected to exactly two other devices, forming a closed loop or ring. Data circulates around the ring in one direction. When a device receives data, it processes it and passes it along to the next device until it reaches its destination. Fifth one is the mesh topology. Mesh topology is like a web of connections where each device is connected to every other device. This creates redundancy and multiple paths for data to travel. Mesh networks can be either full mesh or partial mesh. Tree topology. A tree topology combines characteristics of star and bus topologies, arranging nodes in a hierarchical structure that resembles a tree. In this layout, multiple star networks are connected to a central bus, allowing for a scalable and organized network design. Think of a family tree where each branch represents different family members connected to a common ancestor. Similarly, in a tree topology, the central node acts as a trunk with branches extending to various subnodes. Hybrid topology. A hybrid topology combines two or more different topologies into a single network. This is often done to harness the strengths of one topology while mitigating its weakness. For example, a network might use a star topology for its core infrastructure and a bus topology for smaller isolated segments. So where can we use this network topology? Bus topology can be used in small networks. Ring topology applications requiring data integrity such as token based networks. Mesh topology high availability environments like mobile and ad hoc network and air traffic control system. Star topology in modern Ethernet LANs. Tree topology in large organization. Hybrid topology using in all kinds of applications. So what is the best type of network topology? The best type of network topology depends on the factors you care about the most. Here are some factors and the best type of network topology for it. For low cost, bus and star topology is preferable. For high reliability, mesh and hybrid topologies are reliable. For high scalability, tree and mesh topologies are advisable. And for high performance, mesh and star topologies are advisable.